Welcome back to our engineering lecture series YouTube live session. My name is Aruna, faculty from ACE Engineering College. Today I will explain, this is the last session continuation. Already in the last session I explained how to find out the particular integral. So when q of x is equal to e power ax, when q of x is equal to sin ax or cos ax, when q of x is equal to x power m. Now today I will explain. So what is the overview of this session is, so today particular integral of f of d into y is equal to q of x when q of x is equal to e power ax into v of x. E power ax into v of x when v of x is some function. Next, particular integral of f of d into y is equal to q of x when q of x is equal to x power m into v of x. X power m into v of x. These two are the direct methods to find out the particular integral. Next one is method of variation of parameters, is very important method. So this is the method of variation of parameters. Next, equations reducible to linear differential equations with constant coefficients. How to reduce a differential equation with variable coefficient into constant coefficient, that is our last topic. So what is the fourth method? So this is the fourth method to find the particular integral of a given function. So here, what is when we apply this method, when q of x is equal to e power ax into v of x. When q of x is equal to e power ax into v of x, where v of x is some particular function sin ax or cos ax or x power m. Where q of x equal to sin ax or cos ax or x power m. In this case, how to find its particular integral? Actually, what is the definition of particular integral? So, definition of particular integral is equal to yp is equal to 1 by f of d into q of x. 1 by f of d into q of x. Now here, which is equal to 1 by f of d into, what is the q of x here? Q of x is equal to e power ax into v of x. E power ax into v of x. How to find out this particular integral when a function v of x is multiplied by e power ax? So what is the step here? Take this e power ax left side of 1 by f of d and replace every d with d plus a in f of d. Replace every d with in f of d. Replace every d with d plus a in f of d into v of x. Now here, what is the v of x? Where v of x equal to sin ax or cos ax or x power m. So now here, operate this 1 by f of d plus a into v of x using the previous methods. When v of x is equal to sin ax or cos x, apply second method. When v of x equal to x power m, apply the third method. This is the procedure to find the particular integral when q of x equal to e power ax into v of x. So by the definition of particular integral is 1 by f of d into q of x. And so to find the particular integral, take e power ax left side of 1 by f of d and replace every d with d plus a. These two are the important key points. Take e power ax left side of 1 by f of d and replace every d with d plus a in f of d and operate with v of x using the previous methods. That is how to write this one. Particular integral is equal to 1 by f of d into e power ax. Symbolically we can write e power ax into 1 by f of d plus a into v of x. This is the procedure. So we will see previous questions. First question, solve. D square plus 2d plus 1 into y is equal to e power x into sin x. So this is the solve, means we have to find out the general solution. So how to find out the general solution of this differential equation? Now here this equation 1 is of the form, is a non-homogeneous linear differential equation. So equation 1 is of the form, equation 1 is of the form, yes, what is the standard form? Standard form is f of d into y is equal to q of x. F of d into y is equal to q of x. So where, what is f of d? Where, just compare the given equation with this standard form and write f of d. So where f of d is equal to d square plus 2d plus 1. And q of x, what is the q of x? Q of x is equal to e power x into sin x. E power x into sin x. So now here the general solution is in two parts. First part is complementary function, second part is particular integral. So first we have to find out the complementary function. To find the complementary function, first consider auxiliary equation. So consider here auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m is equal to 0, which is obtained by replacing d by m in f of d and equate to 0 and solve this equation. We will get roots. So how to write here f of m? F of m is m square plus 2m plus 1 is equal to 0. So m square plus 2m plus 1 is nothing but that is m plus 1 whole square. So what are the factors? M plus 1 into m plus 1 is equal to 0. So from this equation, so what are the roots? From these two factors, roots are minus 1 comma minus 1. So when m is equal to minus 1 comma minus 1, what is the nature of the roots? So here roots are real and equal. When the roots are real and equal, how to write its complementary function? So therefore, complementary function of equation 1 is, complementary function of equation 1 is denoted with yc is equal to. So here roots are real and equal. So in this case, how to write? This one is c1 plus c2x into e to the power minus x. c1 plus c2x into e power minus x. Consider this one as equation 2 and this equation 2 is the first part of the general solution. So this is complementary function. Complementary function completed. Next, how to find out the particular integral. So what is the particular integral? Next heading is particular integral. So first write the definition of particular integral. What is the definition of particular integral? We have yp is equal to 1 by f of d into q of x. 1 by f of d into q of x. Where? What is the q of x here? Here q of x is equal to e power x into sin x. E power x into sin x is of the form e power ax into v of x form. E power ax into v of x. When q of x equal to e power ax into vx, how to write the particular integral? First write 1 by, what is f of d? F of d is d square plus 2d plus 1 into q of x. What is the q of x? E power x into sin x. What is the procedure here? Take e power x left side and what is the a value here? If we compare these two, what is the a? A is equal to 1. So, take e power x left side of 1 by f of d and replace every d with, this is the important point, replace every d with d plus 1. So, d plus 1 whole square plus 2 into d plus 1 plus 1 into sin x. Next, simplify this denominator and which is equal to, so don't operate any function with e power x. So keep it as it is 1 by, so d plus 1 whole square, that is d square plus 2d plus 1 plus again 2 into d plus 2 plus 1 into sin x, which is equal to e power x into 1 by, simplify this one, which is equal to d square 2d plus 2d, that is equal to 4d. Next, plus 1 plus 2 plus 3 plus 1, that is equal to plus 4 into sin x. Fourth method completed, but how to operate this one? So, how to operate this 1 by d square plus 4d plus 4. So, when q of x is equal to sin x or cos x, put d square is equal to minus a square. Now here put d square is equal to, so in sin x, what is the x coefficient here? 1. So put d square is equal to minus 1 square, that is equal to minus 1. That is not minus 1 whole square, that is minus 1 square. So therefore yp is equal to, so yp is equal to e power x into 1 by, what is the d square? D square is equal to minus 1 plus 4d plus 4 into sin x. Again simplify this one, which is equal to e power x into 1 by minus 1 plus 4, that is equal to plus 3 plus 4d into sin x. Again, after substituting d square is equal to minus a square, here this denominator contains d terms. In this case, how to change this denominator as a even powers of d? Rationalize it. Okay. So that means multiply and dividing with the conjugate factor of 3 plus 4d. So now multiply and dividing with 3 minus 4d. So 3 minus 4d by denominator 3 plus 4d into 3 minus 4d. So that is equal to 9 minus 4d. So that is equal to 16d square. 9 minus 16d square. So 3 square is 9 minus 16d square into sin x. After rationalization, again denominator contains d square. When the denominator contains e, then put d square is equal to minus 1. So now which is equal to e power x into 3 minus 4d by 9 plus. If we put d square is equal to minus 1, minus into minus plus 16 into sin x. Now here, what is the operation? Put d square is equal to minus 1 square, that is equal to minus 1. Okay, what is the denominator here? 9 plus 16, that is equal to 25. So what is the denominator? That is equal to e power x by 25 into s. What is the next numerator is? 3 minus 4d. 3 minus 4d into sin x. Okay, next which is equal to e power x by 25. Next operate 3 minus 4d with sin x. That means multiply 3 minus 4d with sin x. 3 into sin x. 3 into sin x minus 4 into where? What is the capital D? Capital D is the differential operator where capital D is equal to d by dx. Is the differential operator. Minus 4 into d into sin x. So which is equal to e to the power x by 25 into 3 sin x minus 4 into differentiation of sin x. What is the differentiation of sin x? Cos x. So e power x by 25 into 3 sin x minus 4 cos x is the particular integral. So therefore, what is the yp? Yp is equal to e power x by 25 into 3 sin x minus 4 cos x. So this is the second part of the general solution. Let us consider is equation number 3. Next, write the general solution. What is the general solution? So therefore, general solution of given equation. Equation 1 is from equations 2 and 3. How to write the general solution? Y is equal to yc plus yp. So that implies y is equal to yc. So what is the yc? From equation 2. From equation 2, yc is equal to c1 plus c2x into e power minus x. c1 plus c2x into e to the power minus x plus. From equation 3, what is the yp? E power x by 25 into e power x by 25 into 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. So, this is the required general solution of a given differential equation. This is the required general solution of a given differential equation. Once again, see the solution. So, first, write the given equation into standard form. From that one, write required f of d and q of x. He is a non-homogeneous linear differential equation. Here, general solution contains two parts. First one is complementary function. How to find out the complementary function? Consider an auxiliary equation. What is the auxiliary equation? F of m is equal to 0. Now, here, this f of m is m square plus 2m plus 1 equal to 0. If we simplify this one, we get the roots are minus 1 and minus 1. Here, what is the nature of the roots? Roots are real and equal. When the roots are real and equal, so this is the complementary function c1 plus c2 x into e power minus x. Next one is particular integral. So, what is the particular integral definition? 1 by f of d into q of x. Now, substitute the given terms 1 by d square plus 2d plus 1 into e power x into sin x. Now, here one function is multiplied with exponential. So, here apply fourth method. So, what is the fourth method? Take e power x left side and replace every d with d plus 1 in f of d and operate this 1 by f of d plus a in with sin x. So, here after substituting this one, we get e power x into 1 by d square plus 4d plus 4 into sin x. Now, here if you observe clearly, so which is independent term, that is sin x. So, when it is sin x, apply the second method. What is the second method? Substitute d square is equal to minus a square. So, put d square is equal to minus a square. So, if we substitute d square is equal to minus a square, again here denominator contains d terms. When the denominator contains d terms, rationalize it. Again, if denominator contains even powers, again substitute d square is equal to minus a square. So, if we substitute d square is equal to minus a square, so we get this is e power x by 25, 3 minus 4d into sin x. Don't stop here. This is not a particular integral because here we have one d. D is nothing but is a differential operator. So, operate sin x with 3 minus 4d, then we get 3 into sin x minus 4 into d into sin x. What is a d? D is nothing but differential operator, that is d by dx, that is equal to cos x. Differentiation of sin x is cos x. So, this is the particular integral. At last, write the general solution is y equal to yc plus yp. This is the required general solution. Next question. Find the particular integral of. Here, what is the question? Only particular integral. Particular integral of d square minus 1 into y is equal to e power x into cos x. So, if we consider is equation 1, what is the standard form of equation 1? So, equation 1 is of the form. Equation 1 is of the form. Equation 1 is of the form. What is the standard form here? Standard form is f of d into y is equal to q of x. F of d into y is equal to q of x. Where? What is the f of d? Where f of d? F of d is equal to d square minus 1. F of d is equal to d square minus 1. And what is the q of x? Q of x is equal to e power x into cos x. Now, this is of the form. This RHS is of the form. Which is of the form? E power ax into v of x form, where v of x is equal to cos x here. So, therefore, here we need to find only particular integral. So, what is the particular integral definition? By the definition of particular integral, how to write particular integral is yp. Yp is equal to 1 by f of d into q of x. This is the definition of particular integral. And what is the f of d here? So, 1 by f of d is nothing but d square minus 1 into q of x. Q of x is equal to e power x into cos x. E power x into cos x. What is our procedure? So, here procedure is take e power x left side. Now, here what is x coefficient is 1. That is a. So, take e power x left side and replace every d with d plus 1. So, replace every d with d plus 1. X coefficient is 1. So, that is d plus 1 whole square minus 1 into cos x. So if we simplify this one, which is equal to e power x into, what is the continuation of last step, that is 1 by d plus 1 whole square. So d plus 1 whole square minus 1 into cos x. Simplify it, which is equal to e power x into, what is the expansion of d plus 1 whole square? So d plus 1 whole square is d square plus 2d plus 1 minus 1 into cos x. Now here minus 1 plus 1 get cancelled. So what are the remaining terms here? Which is e power x into 1 by d square plus 2d. d square plus 2d into cos x. Again, how to operate this one? Here, what is the RHS here? Term is cos x. When it is q of x is equal to sin x or cos x and denominator contains even powers of d, so then put d square is equal to minus 1. So if we substitute d square is equal to minus 1 plus 2d. Minus 1 plus 2d into cos x. Now here what is the substitution term? Put d square is equal to minus 1. So after substituting d square is equal to minus 1, again denominator contains d terms. So how to write this one? Which is equal to e power x into 1 by, so that is 2d minus 1. Yes, 2d minus 1 into cos x. 2d minus 1 into cos x. When the denominator contains d terms, what is the next? How to change denominator as even powers of d? Rationalize it. So now here what is the rationalization factor? That is 2d plus 1. 2d plus 1 by, if we rationalize it, 2d minus 1 into 2d plus 1. So that is equal to 4d square minus 1. So 4d square minus 1 into cos x. Again, repeat the same procedure. When denominator contains d square, so put d square is equal to minus 1. So that is e power x into 2d plus 1 by, if we put d square is equal to minus 1, that is equal to minus 4 minus 1 into cos x. Here what is the operation? Put d square is equal to minus 1. And what is the denominator? Minus 4 minus 1, minus 5. How to write? Minus e power x by 5 into, operate this cos x with 2d plus 1. So how to write? 2 into differentiation of cos x. What is the differentiation of cos x? Minus sin x plus cos x. Again, multiply this total term with this minus sign. We can write this equation as e power x by 5 into 2 into sin x, minus into minus plus, again minus cos x. So what is this value? Particular integral. Here we need only particular integral. So this is the required particular integral when q of x is equal to e power x into cos x. So first write the standard form. From that one take f of d and q of x using the definition of particular integral and identify q of x, where q of x is e power ax into v of x form. So in this case what is the procedure? Take exponential left side and replace every d with d plus a. After substituting in place of d plus 1, so then this is the term d square plus 2d. When the denominator contains only when the denominator contains even powers and this is a cos x. Apply the second method. What is the second method procedure? Put d square is equal to minus 1. If we substitute d square equal to minus 1, this is minus 1 plus 2d, but it contains d terms only. So therefore rationalize it. We get that is e power x into 2d plus 1 by 4d square minus 1 into cos x. When the denominator contains d square terms, substitute again. Put d square is equal to minus 1. Operate it. So this is the required particular integral. Next, solve. d cube plus 2d square plus d into y is equal to x square into e power 2x. Dear students, try to find the complementary function and post your answer in chat box. So this is, if we consider, is equation 1. So equation 1 is of the form. Equation 1 is of the form. Yes, what is the standard form? Standard form is f of d into y is equal to q of x. F of d into y is equal to q of x. Where? What is f of d? Where f of d? F of d is equal to d cube plus 2d square plus d. And q of x. What is the q of x? Q of x is equal to x square into e power 2x. Rewrite this one into the standard form, that is e power 2x into x square, which is of the form e power ax into v of x. So first here, this is the question, solve. Solve means find the general solution. So to find the general solution, first we have to write the complementary function. So what is the complementary function? First consider auxiliary equation. So what is the auxiliary equation? Consider an auxiliary equation, that is f of m is equal to 0. F of m is equal to 0. What is f of m here? So that is, just replace d by m in f of d, that is m cube plus 2m square plus m is equal to 0. Now here we have one common term, so that is m. So if you take m is outside, and what are the remaining terms? M square plus 2m plus 1 is equal to 0. So m square plus 2m plus 1 is what? M plus 1 into m plus 1. So what are the factors? M into m plus 1 into m plus 1 is equal to 0. So from this equation, what are the roots? M is equal to 0, comma, minus 1, comma, minus 1. All the roots are real, but out of 3, 2 roots are equal. So in this case, how to write? It's a complementary function. So what are the roots? Roots are m equal to 0, comma, minus 1, comma, minus 1. So therefore, complementary function yc is equal to. So here out of 3 roots, these two are equal. So first write the corresponding part of distinct root. So that is c1 into e power 0x plus. Next 2 roots are equal, real and equal. So in this case, how to write? That is c2 plus c3x into e to the power minus x. But what is the e power 0? E power 0 is 1. So that is c1, that implies yc is equal to c1 plus c2 plus c3x into e to the power minus x. This is the complementary function, means first part of the general solution. Next, how to find the particular integral. So to find the particular integral, first write the definition. What is the definition of particular integral? By the definition of particular integral, we have yp is equal to 1 by f of d into q of x. This is the definition. Now here what is the f of d? F of d is equal to 1 by d cube plus 2d square plus d into, what is the q of x? Q of x is equal to e power 2x into x square. E power 2x into x square is of the form e power ax into v of x. What is the a value here? A is equal to 2. So what is the procedure? Take this e power 2x left side and replace every d with d plus 2. So replace every d with d plus 2, that is d plus 2 whole cube plus 2 into d plus 2 whole square plus d plus 2 into x square. So before going to apply the direct method, first operate this one. So what is that simplification? D plus 2 whole cube is equal to e power 2x into 1 by d plus 2 whole cube. So that is d cube plus 3a square b. So that is equal to 6d square plus 12d plus 2 cube is 8. If we expand this one, a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So if we expand that one, which is d cube plus 6d square plus 12d plus 8. What about next one? 2 into d plus 2 whole square. So that is plus 2 into d plus 2 whole square. What is the d plus 2 whole square? D square plus 4d plus 4 plus. Last term is d plus 2. So last one is d plus 2 into x square. Now simplify the denominator, e power 2x into 1 by, so cube terms, d cube, see here, 6d square plus 2d square, 6 plus 2 that is equal to 8d square. Next, d terms, 12d, 4 2s are 8, 12 plus 8, 20d plus 1, so that is equal to 21d. Next, plus constant terms, 8 plus 4 2s are 8, 8 plus 8 is 16 plus 2, that is equal to 18 into x square. Next, how to operate this one? Using the previous methods. Now here, this is of the form 1 by f of d into x power m. 1 by f of d into x power m. What is that procedure? In this case, reduce this 1 by f of d to the form 1 by 1 plus or minus phi of d. So how to reduce? By taking out lowest degree term from f of d. Now here, what is the lowest degree term here? 18. So take 18 is outside, which is equal to e power 2x by 18 into 1 by, if we take 18 is outside, that can be written as 1 plus d cube plus 8d square plus 21d by 18 into x square. So reduce 1 by f of d to the form 1 by 1 plus or minus phi of d by taking out lowest degree term. Now here, what is the lowest degree term is 18. So take 18 is outside. Again, how to write this one? E power x by 18. So this 1 by 1 plus or 1 plus, this one can be written as 1 plus d cube plus 8d square plus 21d by 18 whole inverse into x square. So what is the expansion of this one? So what is the expansion? 1 plus phi of d whole inverse expansion, binomial expansion. So expand in ascending powers up to the term containing d power m. So that is equal to, what is the expansion of this one? 1 minus phi of d plus phi of d whole square minus phi of d whole cube plus so on. This is the expansion. Now here, what is our term? Which is equal to e power x by 18, e power x by 18 into 1 plus d cube plus 8d square plus 21d, 8d square plus 21d by 18 into x square. So which is, what is the expansion of this one? Which is equal to e power x by 18 into 1 plus phi of d whole inverse, 1 minus phi of d. So now here, what is the phi of d? This total term, d cube plus 8d square plus 21d by 18 is the phi of d. So 1 minus phi of d. So what is the phi of d? 1 by 18 into d cube plus 8d square plus 21d. Next, plus phi of d whole square. So phi of d whole square. So that is equal to plus 1 by 18 square. 1 by 18 square is nothing but 1 by 324 into d cube plus 8d square plus 21d whole square whole into x square. First, neglect the higher order derivatives. So now which is equal to e power x by 18 into 1 minus 1 by 18 into 3 times here what is the x square? 3 times differentiation of x square 0. So ignore that term and 8d square plus 21d. Next plus 1 by 324. If we expand this one, d cube whole square, so that differentiation is, the differentiation of x square is 0. Next 8d square whole square, d power 4 of x square is 0. Next 21d square, so 21 is nothing but 441, 21 whole square is 441 into d square into x square. Now operate this total expression with x square, so we get which is e power x by 18 into x square into 1 x square minus 1 by 18 into 8 into 2 times the differentiation of x square. 2 times the differentiation of x square is 2. Next plus 21 into differentiation of x square is 2x. 1 time differentiation of x square is 2x plus 1 by 324 means 441 by 324 into 2 times the differentiation of x square is 2. So if we simplify this one, which is equal to e power x by 18 into x square minus, if we take 2 is outside, that is equal to 1 by 9 into 8 plus 21x plus, so that is equal to 441 by 162. So this is the required particular integral. So this is the particular integral only, yp. Next write the general solution. So what is the general solution? See here. Therefore, general solution is y is equal to yc plus yp. What is the yc? yc is c1 plus c2 plus c3x into e power minus x plus yp. So this is the yp. yp is equal to e power x by 18 e power x by 18 into x square minus 1 by 9 into 8 plus 2x plus 441 by 162. So this is the required general solution of a given differential equation. This is the required solution. So these are the problems, previous questions from fourth method. That means when q of x equal to e power ax into v of x. This is the solution. Next, fifth method. When q of x is equal to x power m into v of x, where v of x equal to sin x or cos x. Suppose when v of x equal to e power x, in this case don't go for fifth method, directly apply the fourth method only. So where what is the v of x? Sin ax or cos ax. In this case, how to find the particular integral? Here we have two cases. First case, case 1 is if m is equal to 1. If m is equal to 1, what is the definition of particular integral? Yp is equal to 1 by f of d into s. What is our q of x? Q of x is equal to x power m. m is equal to 1. x into v of x. x into v of x. So when we apply this case 1 is when m equal to 1 and here v of x equal to sin x or cos x. And if we replace d square by minus a square in f of d and if the denominator is non-zero, then only apply this case. So now here we have direct formula for this one, which is x minus f dash of d by f of d into 1 by f of d into q of x. What is the q of x here? sin ax or cos ax. Using the second method, operate this 1 by f of d into q of x in both the cases. This is direct to formula. When m is equal to 1, when m equal to 1, here v of x is sin ax or cos ax. And one more condition, after replacing d square by minus a square, if the denominator is non-zero, then apply this formula. This is the first case. So then particular integral definition, and what is the formula? X minus f dash of d by f of d into 1 by f of d into v of x. This is direct formula. When we apply this formula, when m equal to 1 and after replacing d square by minus a square and denominator is non-zero, then only apply this formula. Next, case 2. When m is not equal to 1 and v of x is equal to sin ax. When m is not equal to 1 and v of x equal to sin ax, how to write the particular integral? Yp is equal to 1 by f of d into x power m into sin ax. X power m into sin ax. Here we are unable to apply the previous formula. Okay. So which is equal to 1 by f of d into, how to reduce this one? Reduce this total entire method into fourth method form. What is the fourth method? Fourth method is e power ax into v of x form. So but here x power m, here we are unable to write x power m in exponential, but we can write sin ax in terms of exponential. How to write sin ax in terms of exponential? What is the e power I theta formula? E power I theta is equal to cos theta plus I into sin theta. So now we know that in a complex number z equal to x plus iy. So this first part is called real part, second part is called imaginary part. Now here this cos theta is called the real part. So that means real part of so here we can write this is cos theta is real part of e power I theta. And how to write sin theta? Sin theta can be written as sin theta is the imaginary part of e power I theta. Now here what we have? Sin ax. How to write this sin ax? Sin ax can be written as imaginary part of e to the power iax. Next, take this imaginary part is entirely outside, that is imaginary part of. Don't ignore that word, that term. At last we pick only imaginary part from the complex number. So that's why just write outside imaginary part of. How to write this one? 1 by f of d into e to the power iax into x power m. What is the previous method? When a function is multiplied with exponential, take e power iax left side. So how to write this one? Imaginary part of, take e power iax left side and replace every d with d plus ia. So f of d plus ia into x power m. Again operate this 1 by f of d plus ia into x power m using known method, third method. So at last write this entire term as a complex number. From that complex number we need only imaginary part. That imaginary part gives the required particular integral. Suppose when v of x is equal to cos ax, in this case how to write this cos ax as a real part of e power I theta. That means here how to write real part of e power iax and apply the same procedure. So how to write imaginary part of e power iax. At last imaginary part of 1 by f of d into x power m into e power iax and operate this one using the fourth method. Similarly 1 by f of d into x power m into cos ax. Cos ax can be written as real part of e power iax. This is the method. Yes, first question, solve. D square minus 1 into y is equal to x into sin x. D square minus 1 into y is equal to x into sin x. First, write the standard form of equation 1. So, equation 1 is of the form, equation 1 is of the form, yes, what is the standard form? Is a non-homogeneous. So, what is the non-homogeneous standard form? F of d into y is equal to q of x. F of d into y is equal to q of x. Where? What is f of d? Where f of d is equal to, yes, what is f of d here? Where f of d is equal to d square minus 1. D square minus 1. And what is the q of x? Q of x is equal to x into sin x. X into sin x is of the form? Is of the form x into v of x. What is the v of x here? Sin x. So first find the complementary function. So how to find out the complementary function? By considering an auxiliary equation. So consider an auxiliary equation. What is the auxiliary equation? F of m is equal to 0. Yes, what is the f of m here? F of m is m square minus 1 is equal to 0. M square minus 1 is 0 is not m minus 1 into m plus 1. So that means roots are plus or minus 1. So that is m is equal to minus 1 comma plus 1. So minus 1 comma plus 1. So roots are real and distinct. Roots are real and distinct. When the roots are real and distinct, real and distinct. When the roots are real and distinct, how to write the complementary function? Yc is equal to c1 into e power minus x plus c2 into e power plus x. This is the complementary function. Next, how to find out the particular integral? So now particular integral can be written as, from the definition of particular integral, we can write yp is equal to 1 by f of d into q of x. This is the definition of particular integral. Now here what is the f of d? 1 by d square minus 1 into q of x. Q of x is x into sin x. So here apply case 1 when m equal to 1 and here a equal to 1. If we replace d square by minus 1, this denominator is not equal to 0. In this case, apply the formula. So what is the formula? Formula is 1 by f of d into x into v of x. Formula is x minus f dash of d by f of d into 1 by f of d into v of x. 1 by f of d into v of x. In this question, v of x is equal to sin x. Now apply that formula, which is x minus f dash of d. What is f of d here? F of d is equal to d square minus 1. What is the f dash of d? 2d minus 0 by f of d. So that is d square minus 1 into, again, what is the next? 1 by f of d. 1 by d square minus 1 into sin x. So operate this one with sin x. When it is sin x or cos x, put d square is equal to minus a square. So put d square is equal to minus 1 square, that is equal to minus 1 in both the cases. So in both the terms, that is equal to x minus 2d by d square is equal to minus 1 minus 1 minus 1 minus 2 into 1 by d square equal to minus 1 minus 2 into sin x. How to write this one? Which is equal to minus 1 by 2 into, next, multiply the sin x with x minus 2d. So that is x into sin x. Next, 2 get cancelled and minus into minus plus differentiation of sin x. What is the differentiation of sin x is? cos x. This is the required particular integral. So how to write the general solution? So therefore, general solution is y is equal to yc plus yp. So that implies y is equal to, what is the yc here? Yc is c1 e power minus x plus c2 e power plus x. c1 into e power minus x plus c2 into e power plus x. Next, what is the yp? Yp is minus 1 by 2 into x sin x plus cos x. X sin x plus cos x. This is the required general solution. Is the required general solution of a given differential equation. Next question. Find the particular integral of d square plus 1 into y equal to x cos x. Yes, if we consider is equation 1 is of the form equation 1 is of the form. Yes, what is the standard form? Here standard form is f of d into y is equal to q of x. Dear students, try to find the complementary function and post your answer in chat box. Where? What is f of d? Where f of d is equal to d square plus 1. And what is the q of x here? Q of x is equal to x into cos x is of the form. X into cos x is of the form x into v of x. X into v of x. First, find the complementary function. Complementary function. To find the complementary function, consider an auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m is equal to 0. Yes, what is f of d here? D square plus 1. So then what is the f of m? So from this we can write that is equal to m square plus 1 is equal to 0. So m square plus 1 equal to 0 is nothing but what are the roots? M is equal to plus or minus I. So now here what are the roots? So these roots are the form alpha plus or minus I beta. Now here roots are complex and distinct. So therefore how to write the complementary function? Yc is equal to here alpha is equal to 0. That means e power 0x into c1 cos beta x. What is the beta here? 1. c1 cos x plus c2 sin x. But what is the e power 0? E power 0 is equal to 1. So yc can be written as c1 cos x plus c2 sin x. This is the required complementary function. Next, to find the particular integral. Yes, how to find out the particular integral? Now see here, wait. Sorry, here we have to find only particular integral, no need to calculate the complementary function. Yes, what is the particular integral? Particular integral is yp is equal to 1 by f of d into q of x. What is f of d here? 1 by d square plus 1 into x cos x. Observe clearly. Observe clearly. Now here m equal to 1 but replacing d square by minus a square. So d square by minus a square. What is the a value here? 1. If we put d square is equal to minus 1 plus 1. So what is a minus 1 plus 1? 0. So that's why no need to apply the don't apply the first case. Now here how to write this cos x? Now write this cos x in terms of exponential. So how to write? Which is equal to 1 by d square plus 1 into x into. How to write cos x? Cos x is the real part of e to the power ix. Is the real part of e power ix. So reduce this one into fourth method form, e power ax into v of x. Next, how to write this one? Which is equal to real part of 1 by d square plus 1 into e to the power ix into x. E power ix into x. Now here, which is in the form of e power ax into vx form. So what is the procedure? Real part of, take e power ix left side and replace every d with d plus I. So that is d plus I whole square plus 1 into x. Just apply fourth method only. So next, what is the next step? That is equal to real part of e power ix into 1 by d plus I whole square. So d plus I whole square is nothing but d square plus 2id plus I square. I square is minus 1 and what is the remaining term? Remaining term is plus 1. So plus 1 into x, which is equal to real part of e to the power ix. Here plus 1 minus 1 get cancelled. What are the two terms? D square plus 2id into x. If you know an idea about the previous methods, then only we can solve these questions. Here again apply which method? Third method. So what is the third method procedure? Third method procedure is reduce 1 by f of d to the form 1 by 1 plus or minus phi of d by taking out lowest to degree term. Here what is the lowest to degree term? 2id. So if we take the term is outside, that can be written as 1 plus d by 2i. 1 plus d by 2i into x. Again, which is equal to real part of e to the power ix by 2id into, again how to write this one, which is equal to 1 plus d by 2i whole inverse into x. So expand in ascending powers of d up to the term containing d only, because if we take the higher derivatives, higher derivative d square of x is 0, d cube of x is 0. So no need to take the higher derivatives. How to write this one, which is equal to real part of e to the power ix by 2id into. So just expand this one. This is 1 by d minus 2i into x. Next, operate x with 1 minus d by 2i. That is equal to real part of is equal to real part of e to the power ix by 2id into 1 minus d by 2i. So that is equal to x minus 1 by 2i into differentiation of x is 1. So which is equal to real part of e to the power ix by 2d. If we take this 1 by I inside, so that is equal to 1 by I can be written as minus I. 1 by I is minus I into I square is minus 1. Minus into minus plus 1 by 2. 1 minute. So now here we have x. So that is equal to minus x into I plus 1 by 2. Again, here we have one more d. Okay. So if d is the differential operator and take this 1 by 2 is outside, real part of e power ix. What is the e power ix? E power ix can be written as cos x plus I into sin x. Again 1 by d. If d is the differential operator, d is equal to d by dx. What is the 1 by d? 1 by d is nothing but integration of dx. Now integrate this one. So what is the integration of x? Minus I into integration of x is x square by 2 plus integration of 1 by 2 into dx. So that is equal to x by 2. X by 2. So again, so which is equal to, if we take 2 is common from these two terms, so that is 1 by 4 into real part of, so this is one complex number. What is that complex number? Cos x plus I into sin x. Again, write this one also in the form of complex number, x minus I into x square. Now multiply these two complex numbers, that is equal to 1 by 4 into real part of. So if we take first real part, so that is x into cos x plus into minus I into I square minus 1 minus into minus plus x square into sin x. Next, take the coefficients of I. So what are the coefficients of I? If you multiply these two, that is x into sin x minus, next if you multiply these two, that is minus x square into cos x. So again, from this complex number, this is the only real part. This is the imaginary part, but we need only real part of this total complex number. So what is the real part? That is equal to 1 by 4 into x into cos x plus x square into sin x. We need only real part. So take only real part. Don't take imaginary part. So this is the required particular integral. So what is the question? Only find the particular integral. So therefore, particular integral yp is equal to 1 by 4 into x cos x plus x square into sin x. This is the required particular integral. Next. So here we have one important method, that is to solve the second order differential equation. General solution of d square y by dx square plus p into dy by dx plus qy is equal to rx. So what is that method name is? By the method of variation of parameters. By the method of is very, very important. Any second order differential equation can be solved using this method of variation of parameters. So what is the working rule? How to find out the general solution of this one? So first, reduce the given differential equation into standard form. What is the standard form here? D square y by dx square plus p of x into dy by dx plus q of x into y is equal to r of x. After that, same. Find the solution of homogeneous. If it is equal to 0 means complementary function of non-homogeneous, and general solution of homogeneous, and is a second order differential equation. So therefore its complementary function is of the form c1 into u of x plus c2 into v of x. So after writing the complementary function, next here first we have to assume the particular integral. What is the particular integral? A of x into u of x plus b of x into v of x. Take u of x and v of x from the complementary function, and in this particular integral, a of x and b of x are the unknown functions of x. How to find out that unknown function? If we know a and b values, then directly we can write the general solution. But how to find out this capital A and capital B? So first, before going to find the capital A and capital B, first to find the Ranskin of u and v. So what is the Ranskin of u and v? U into dv by dx minus v into du by dx. We can also write this one as, which is equal to u v u dash v dash. Determinant of u v u dash v dash is nothing but this one, that is called the Ranskin of u and v. So next, find a and b. So find a using the formula integration of minus integral v of x into r by w into d of x, and b is equal to integration of u of x into r by w into dx, where w is Ranskin of u and v. So after finding the a and b values, next write the complete particular integral and write the general solution. What is the general solution? Complementary function plus particular integral. So what is the complementary function? C1 into u of x plus C2 into v of x, and particular integral is a of x into u of x plus b of x into v of x, which gives the required general solution of a given second order linear differential equations. This is the maximum times repeated question. Sorry, this is A, tan AX. Yes. Solve d square y by dx square plus a square into y is equal to tan AX by the method of variation of parameters. Same question, d square y by dx square plus 4y is equal to tan 2x. D square y by dx square plus 9y is equal to tan 3x. So this is the general question. So how to find out this one? What is the standard form here? The standard form. So if we consider it is equation 1. So standard form of equation 1 is d square y by dx square plus p of x into dy by dx plus q of x into y is equal to r of x. If we compare these two equations, yes, what is a p? P of x is equal to 0. And q of x, what is the q of x? Q of x is equal to a square. And r of x, what is the r of x? R of x is equal to tan ax. What is our first step? First, to find the general solution of homogeneous equation. That means complementary function. So how to find out the complementary function? So first, to find the complementary function, consider an auxiliary equation. Yes, what is the auxiliary equation here? F of m is equal to 0. What is the f of m here? M square plus a square is equal to 0. M square plus a square equal to 0 is m is equal to plus or minus ai. M is equal to plus or minus ai. Here roots are complex and distinct. When the roots are complex and distinct, how to write the complementary function? Yc is equal to c1 into cos ax plus c2 into sin ax. Now here alpha is equal to 0, e power 0x is 1 directly here, right? Yc is equal to c1 into cos ax plus c2 into sin ax. Okay. So this is equation 2. Again, equation 2 can be written as, what is equation 2? Yc is equal to c1 into cos ax plus c2 into sin ax. Consider this one as c1 into u of x plus c2 into v of x. c2 into v of x. Where? What is the u of x? Dear students, find the Ransky and post your answer in chat box. Where? What is the u of x? U of x is equal to cos ax. And v of x? V of x is equal to sin ax. Next, here write the particular integral. So now write the particular integral as particular integral, that is yp is equal to, how to write particular integral? Before assuming that yp is equal to, what is a yp? A of x into u of x, a of x into u of x plus b of x into v of x. Here u of x and v of x are known functions, but a of x and b of x are the unknown functions. Now substitute u of x into, what is a u of x? U of x is equal to cos x plus b of x into v of x is equal to sin ax. Sorry, this is cos ax sin ax. Next, before going to find a and b, next to find the Ransky. So what is the Ransky? Ransky is determinant of u, v, u dash, v dash. So that is equal to, what is a u? U is equal to cos ax. V is equal to sin ax. U dash, differentiation of cos ax. What is the differentiation of cos ax? Minus a sin ax. V dash, differentiation of sin ax. A cos ax. So if we find the determinant which is equal to a into cos ax into cos ax, that is a into cos square ax minus into minus plus a into sin ax into sin ax, that is equal to sin square ax, we get a only and is not equal to 0. So this is the Ranskean. After finding the Ranskean, next to find a and b values. Calculate capital A and capital B. So now here, what is the a of x? A of x is equal to minus integral v of x into r of x by w into dx, which is equal to minus integral. What is the v of x? V of x is equal to sin ax into r of x is equal to tan ax by w is equal to a into dx. So which is equal to, simplify this one, which is minus 1 by a integration of, tan can be written as sin by cos. Already we have one sin ax, so that can be written as sin square ax by cos ax into dx. So which is equal to minus 1 by a integral. Again, so to integrate this one, write sin square ax as 1 minus cos square ax by cos ax. Write the linear factors. So to write the linear factors, write sin square ax as 1 minus cos square by 1 minus cos square ax minus 1 by a into integration of 1 by cos ax, that is secant ax minus cos square ax by cos ax. Divide term by term. If we divide term by term, 1 by cos ax is secant ax minus cos square ax by cos ax is cos ax into dx. Now, what is integration of secant ax? Which is equal to minus 1 by a into integration of secant ax is log of secant ax plus tan ax by a whole divided by a. This is whole divided by a. Next, minus. What is integration of cos? Integration of cos is sine. So that is equal to sine ax by a. This is the a value. Next, find the b value. So what is the b formula? To find the b of x, we have the formula. What is the b formula? Integration of u of x into r of x by w into dx, which is equal to integral. What is the u of x? Cos ax into r of x is tan ax by w is equal to a into dx, which is equal to 1 by a into integration of. Now here tan ax can be written as sin by cos. Cos get cancelled, so that is equal to, we get only sin ax into dx. What is integration of sin ax? Integration of sin ax is minus cos ax by a. So what is the b value? That is equal to minus 1 by a square into cos ax. So this is the b value. Now substitute a and b values in equation 3. Substitute a of x and b of x in equation 3. So what is the equation 3? So equation 3 is this one, a of x into cos ax plus b of x into sin x. But what is the a of x? A of x is equal to this value. So therefore, equation 3 becomes, means complete particular integral. A of x is equal to minus 1 by a into log of secant ax plus tan ax by a minus sin ax by a minus sin ax by a. into u of x. U of x is nothing but cos ax plus b of x. What is a b of x from the previous simplification? Minus 1 by a square into cos ax. Minus 1 by a square into cos ax into sin ax. Now, if we simplify term by term, so first one is minus 1 by a into a minus 1 by a square into log of secant ax plus tan ax minus into minus plus 1 by a square into here we have cos ax, that is cos ax. Next, minus into minus plus 1 by a square into sin ax into cos ax. Again, we have minus 1 by a square into sin ax into cos ax. Now, minus term plus term get cancelled. So, what is the total particular integral? Is minus 1 by a square into log of secant ax plus tan ax. But it is not a complete general solution. How to write the general solution? Therefore, general solution of equation 1 is y is equal to yc plus yp. So, that implies y is equal to, what is the yc? Yc is c1 cos ax plus c2 sin ax. Next, yp is equal to minus 1 by a square into log of ax plus tan ax into cos ax. This is the required general solution. This is the required general solution of a given differential equation using method of variation of parameters. So, first find the complementary function. From that complementary function, take u of x and v of x. Using that u of x and v of x, write the particular integral as a of x into u of x plus b of x into v of x. Next, write the Ransky and find a and b. Find the a value using the formula minus integration of v of x into r of x by w into dx, and b of x is equal to integration of u of x into r of x by w into dx. At last, write the general solution. This is the general solution. Yes. Next one is equations reducible to linear ordinary differential equation with constant coefficients. With constant coefficients. Already we know that how to solve the general solution of a linear differential equation with constant coefficient. If the given differential equation has variable coefficients, in this case, how to convert the differential equation into linear differential equation with constant coefficients. So, we have two types of equations. First one is Cauchy's homogeneous linear equation. So, what is the standard form of this equation? An equation of the form x power n into nth derivative plus a1 into x power n minus 1 into n minus 1 derivative plus a2 into x power n minus 2 into n minus 2 derivative plus on plus an minus 1 into x into dy by dx plus an into y is equal to q of x. Observe clearly here every differential coefficient contains variable coefficient. Okay, so its coefficient is variable. This type of equation is called the Cauchy's homogeneous linear equation. How to reduce this Cauchy's homogeneous linear equation into linear differential equation with coefficients? Here, change this independent variable. So, by taking x is equal to e power t. If we take x is equal to e power t, from this t is equal to log x. If we change this independent variable, then we get x into dy by dx. X into dy by dx is equal to another operator form, so that is theta y. And x square into d square y by dx square. X square into d square y by dx square becomes theta into theta minus 1 into y. What is the theta here? Where theta is differential operator but with new independent variable t. So where theta is equal to d by dt. So such equation can be reduced to linear differential equation with constant coefficients by putting x is equal to e power t or t is equal to log x. So then x into dy by dx is equal to theta y, where theta is equal to d by d theta. Observe clearly where theta is also a differential operator but with new independent variable t. X square into d square y by dx square is theta into theta minus 1 into y, and x cube into d cube y by dx cube is theta into theta minus 1 into theta minus 2 into y. In all the cases, theta is the differential operator, that is d by d theta. And if we substitute all the values in a given equation, therefore equation 1 becomes linear differential equation with the constant coefficients. And we know that how to solve that linear differential equation with constant coefficients using the previous methods. Yes, solve. X square into d square y by dx square plus 4x into dy by dx plus 2y is equal to e power x. So how to find the general solution? So is a Cauchy's homogeneous linear equation. First reduce this Cauchy's homogeneous linear equation or linear differential equation with variable coefficients into linear differential equation with constant coefficients. Okay, so now here put x is equal to e power t. Change the independent variable. If we put x is equal to e power t, from this we can write t is equal to log x. Then if we take the substitution x is equal to e power t, then x into dy by dx, x into dy by dx is equal to theta y, and x square into d square y by dx square is equal to theta into theta minus 1 into y. So is a second order differential equation. Now if we take these substitutions here, so therefore equation 1 becomes, yes, what is x square into d square y by dx square? Theta into theta minus 1. Theta into theta minus 1 plus 4 into x into dy by dx. X into dy by dx is theta plus 2, combinedly take y is outside, into y is equal to e power x. What is the x? E power t. X is equal to e power t. So totally change the independent variable x. Now simplify this one, which is equal to theta square minus theta plus 4 theta, that is equal to plus 3 theta plus 2 into y is equal to e power t. Is a new differential equation. Now observe clearly, this equation 2 is a new differential equation with constant coefficients, and using the previous procedure find its general solution. At last find general solution of given equation by substituting t is equal to log x. So first of all, this is a new differential equation and 2 is of the form, equation 2 is of the form. Yes, what is the standard form here? Is the standard form f of theta into y is equal to q of t. F of theta into y is equal to q of t. Where? What is f of theta? Where f of theta is equal to theta square plus 3 theta plus 2 and q of t. Now here change the independent variable, that is not x, that is t only. So and what is the q of t? Q of t is equal to e power t. So next, find the complementary function. Students, try to solve the complementary function. Complementary function for which equation? Equation 2. Complementary function of equation 2. So consider here also same procedure. Consider an auxiliary equation. Yes, what is the auxiliary equation? F of m is equal to 0. F of m equal to 0. So here f of m becomes after m is obtained by replacing theta by m. What is f of theta? Theta square plus 3 theta plus 2. So f of m is m square plus 3m plus 2 is equal to 0. Yes, 2 ones are. So how to write this one? M square plus 2m plus m plus 2 is equal to 0. So if we take m is outside from the first two terms, m plus 2 plus 1 is outside, that is m plus 2 is equal to 0. Yes, what are the factors? M plus 1 into m plus 2 is equal to 0. If these two are the factors, then what are the roots? M is equal to minus 1 comma minus 2. Here roots are real and distinct. When the roots are real and distinct, therefore complementary function of new differential equation is yc is equal to c1 into e to the power. What is independent variable here? In equation 2, what is independent variable? T. So write complementary function of that equation also in terms of t. So c1 into e power minus t plus c2 into e to the power minus 2t. So this is the complementary function of not a given equation. Complementary function of equation 2. Next. Particular integral. Yes, what is the particular integral definition? 1 by f of theta. In place of d, take theta. F of theta into q of t. Yes, what is f of theta? 1 by, and observe clearly here, q of t is equal to e power t. So here we are unable to apply the direct methods to find the particular integral. Here we are unable to apply the direct methods to find the particular integral. In this case, and observe clearly, is a second order linear differential equation. Here we can apply the method of variation of parameters to find the particular integral. Okay. So yes. Here find the particular integral by the method of variation of parameters. Why we apply this one? That e power t is not in the direct methods form. So that's why apply the method of variation of parameters. By the method of variation of parameters. Yes, what is the method of variation of parameters? First write the complementary function. Already complementary function completed. So yc is equal to c1 into e power minus t plus c2 into e to the power minus 2t. So let us consider this one is c1 into u of t plus c2 into v of t. Where? What is a u of t? Where u of t is equal to e power minus t and v of t is equal to e to the power minus 2t. So next, using this u and v, consider particular integral or assuming the particular integral. Now particular integral can be written as yp is equal to, yes, what is the particular integral here? Particular integral is a of t into u of t plus b of t into v of t. What is the, here a of t and b of t are the unknown functions. Now substitute known functions a of t into, so that implies yp is equal to a of t into, what is the u of t? U of t is equal to minus t plus b of t into, what is the v of t? E power minus 2t is equation number Next, write the Ranskean. So what is the Ranskean formula? That is determinant of u, v, u dash, v dash. So which is equal to u. What is the u? U is equal to e power minus t and v is equal to e power minus 2t. U dash, what is the differentiation of e power minus t? Minus e power minus t. V dash, differentiation of e power minus 2t is minus 2 into e power minus 2t. If you find the determinant, that is equal to minus 2 into e power minus 3t, minus into minus plus e power minus 3t. So that is equal to minus e power minus 3t. So that is minus e to the power minus 3t is not equal to 0. So this is the Ranskean, but we have to find a of t and b of t value. Now what is the a of t? Formula is a of t is equal to minus integral v of t into r of t by w into dt. Now what is the v of t here? Integral. So what is the v of t? V of t is equal to e power minus 2t. E power minus 2t into r of t is e power t by, what is the w? Minus e power minus 3t minus e power minus 3t into dt. So if we simplify this one, minus into minus plus e power minus 2t plus 3t. So that is equal to e power t into e power t into dt. So integrate it. So here also that is your choice, integration part. Take the substitution or apply the formula. So take e power t is equal to z. If we take e power t is equal to z, what is the differentiation of e power t? E power t into dt is equal to dz. If we substitute that one here, which is equal to e power t into dt z and e power z into dz. What is integration of e power z? E power z only. But e power, what is the z? Z is equal to e power t. So this is the a of t value. So therefore, a of t is equal to e power t. Next, find the b of t value. Yes, what is the b of t formula? B of t formula. So here b of t is equal to integral u of t into r of t by w into dt. Yes, what is the u of t? U of t is equal to e power minus t, which is e power minus t into r of t. R of t is e power t by w is equal to e power minus 3t minus e power minus 3t into dt. So which can be written as minus integral e power minus t plus 3t. So that is equal to e power 2t into e power t into dt. Again take the substitution form. Before going to take the substitution, right, this e power 2t can be written as e power t into e power t into e power t into dt. If we take e power t is equal to z, what is the differentiation of e power t? E power t into dt is equal to dz. So here if you apply that one, which is e power t into dt is equal to z. So that is minus z into e power z into dz. What is integration of z into e power z by integrating by parts? Minus e power z into z minus 1. But what is the z value? E power t minus e power t into e power t minus 1. That is a b value. Next, write the combined particular integral. So therefore, yp is equal to a of t. What is the a of t? A of t is equal to e power t. E power t into u of t. U of t is e power minus t plus b of t. What is the b of t? B of t is equal to e power t into 1 minus e power t after multiplying with minus sign into v of t. V of t is e to the power minus 2t. E to the power minus 2t. So simplify this one, which is equal to e power minus t into e power t plus e power minus 2t into e power minus 2t into e power t minus ikkada e power t into e power minus 2t, that is e power minus t. Now here minus term plus term get cancelled, and what are the remaining terms? We have only one term, that is e power minus 2t into e power t. So this is the particular integral. Next, write the general solution of new differential equation 2. So write the general solution of equation 2. Equation 2 is y is equal to yc plus yp. Yes, what is a yc? c1 into e power minus t plus c2 into e power minus 2t, and yp is e power minus 2t into e power t. But we need general solution of given differential equation. So put t is equal to log x. If we substitute t is equal to log x, we get the general solution of equation 1. So what is the general solution? Therefore y is equal to c1 into e power, what is the t value? Log x. So c1 into e power minus log x plus c2 into e power minus 2 log x plus e power minus 2 log x into e power. What is the e power t? E power t is equal to x. Again, e power minus log x. How to write e power minus log x? That implies y is equal to c1 into e power minus log x is e power log of x inverse. E power log of x inverse is 1 by x. Next, plus c2 into e power minus 2 log x can be written as 1 by x square. Again, here also same, which is equal to plus 1 by x square into e power x, which is the required general solution of a given differential equation. This is the long answer question. Here you can find the particular integral when q of x is in the directive form. That means q of x is x e power ax sin ax or cos ax or x power m or e power ax into v of x or x power m into v of x. You can apply the direct methods. But q of x is not in that form. Better to apply the method of variation of parameters. Yes, next one is Legendre's linear equation. So what is the Legendre's linear equation? An equation of the form which is similar to the previous one, but in place of x we have a linear factor ax plus b whole power n into nth derivative plus a1 into ax plus b whole power n minus 1 into n minus 1th derivative plus on. So this equation, this type of equation is called the Legendre's equation. How to reduce this equation into linear differential equation with constant coefficient? Same procedure by taking the substitution ax plus b is equal to e power t, where t is equal to log of ax plus b. If we take this is the substitution, then ax plus b into dy by dx is equal to a into theta y ax plus b whole square into d square y by dx square equal to a square into theta minus 1, so on. So if we substitute all these in the given equation, then we get a linear differential equation with the constant coefficients, and using the previous procedure solve the equations on this method. So these are the methods in second unit, unit 2. I hope all you understood the concepts of second unit, how to find out the particular integral when q of x equal to e power ax, when q of x equal to sin ax or cos x, or q of x equal to x power m, or q of x equal to e power ax into v of x, and q of x is equal to x power m into v of x, and the method of variation of parameters and equations reducible to linear differential equations. Thank you everyone.